Lesson 7 of the Enhanced Electric Power Quality and Reliability series, Time Series Data and Data Historians. So we've really come a long way so far in this course, starting out talking about the electric grid and the drivers for the smart grid, the problems that electric utilities are running into, and the need that they have for data to solve it. So we've talked about how they're going to instrument their grids, or how they've already instrumented their grids, and how that data is collected out in the field by the RTUs, and now we even understand how the data is communicated over the network to the servers in the data center to run the SCADA system, and also talked about system integration and how this data passes through a firewall into a corporate LAN where users can get the data and use it for all sorts of activities, value-added activities outside of the core operation of the electric grid. So we've really come a long way, and I want to introduce the concept to you, and we've already talked about this a little bit, but time series data. So when we're collecting these instrument readings, what we're getting is a bunch of time-stamped values from our instruments, right? And anytime we have a list of these time and value pairs, we're talking about time series data. A classic example of time series data, if you go and Google time series data, they're always going to talk about stock prices, right? So you get stock prices, you've got the date and the stock price, and so that's time series data. For our studies, of course, we're primarily concerned with the instrument readings that we're taking. Being able to store this information is a pretty valuable thing, and that should be apparent to you now from all the things that we've talked about. That not only is it important to know what's happening in the grid, but having this historical behavior allows us to analyze the behavior of the grid as we're doing new things to the grid and with the grid. We're running into problems we've never run into before. And so if we've got this data store of values, this time series data historian, we're able to go back and look at how the system has acted over time and look at the interaction of components in the grid. And this is just extremely important. It's not only important in the electric grid, it's important in any kind of manufacturing or process industry. And so here's my example of time series data, and I've actually gone into a data historian. This is data for one tag. Okay, and so I've got my timestamps. I did this today, so from midnight, I took 10-minute readings for this one specific tag, and these are the values that I got. And if I trend that, if I do a visualization of this data, this is what it looks like. Okay, so this is what I'm talking about when I talk about time series data. And you got to remember, in an electric grid, we may have hundreds of thousands or even millions of these. Okay, so I have all the instrumentation I have out there, and all the CTs and PTs I've got on my transmission lines, and all the information I might be collecting from my smart meters, solar panel operation data, temperature of the solar panel, things like that. Every single one of those readings is a tag in my time series database, and I'm collecting this data. And as you can imagine, we can be talking about enormous amounts of data. So let's just go and talk a little bit about databases in general. And everybody's probably heard of a database. You've probably used Microsoft Access on a computer before, or maybe you've even used Excel as a quasi-database. But most of the time when you talk about databases, you're talking about relational databases. And so you might have heard examples of relational databases are Microsoft SQL Server, Oracle is a relational database, PostgreSQL, and MySQL. They're used very commonly in businesses and elsewhere, and an example of this, Facebook uses MySQL extenstively internally. So when you pull up your Facebook page and it's got all your updates from all your friends and everything, all that data is stored in a MySQL database. And these relational databases are table-based. I keep hitting my keyboard here. So they're all table-based, and so this is an example of what the tables look like in the database. So I've got a Microsoft Access screenshot here, and it just shows I've got a table called city that has a city ID and a city name, and then I've got individual. It's got username, password, email address, and city ID. And so if my city ID is 1, I can go look in this table at number 1 and see that maybe that's Palm Beach, Florida. So this is what relational database tables look like, and things that you would use these for would be things like maybe a product catalog. So you have a company that sells a lot of products, and so each one of these would have an entry in a database somewhere that would have the maybe a description of it and a cost of it, the sales price of it and your wholesale cost of it and things like that. Or maybe you have a record for every time you sell something. You would have a sales record, and then there would be it would be linked to another table that would have a bunch of line items in there for each item that you sold in that transaction. So these relational databases have been pretty highly developed. They're widely used in businesses, and this is usually what people think of when you say a database is a relational database. Unfortunately for us, these things are not very good at storing time series data, and we're going to talk about that in a good bit of detail here. But really what you want is a different type of database that is optimized for storing time series information. So we're going to talk about a lot of the characteristics of time series data and different needs of time series data, and kind of develop this concept much more fully during this lecture. But one of the things that you will see is that you can store time series data in a relational database. I could have tag name, timestamp, and value, and just have a table that had tons of those in there, and I could store all that data. And a lot of people do that. It's one of those things that if you're really good with a hammer, everything looks like a nail. A lot of people, they hear database, they think about storing data, they just grab their relational database and go to town with it. But that's not an optimal solution. So I'm going to be drawing quite a bit here, talking about time series data and some of the characteristics of it and some of the needs for being able to store and retrieve this data. So let's just talk here. I'm going to draw a nice little signal, and we're going to go and we're going to take readings of this signal right here. Okay, so periodically I'm going to take a reading on this signal. Okay, and each one of these becomes my little data point. And so I've got my time, t, and my value v. Okay, so I'm going to have t1, v1, t2, v2, t3, v3. Okay, and I could just store this in a relational table and store all these values in there, right? Quick, easy, dirty. You do it, you knock it out, you're done, right? And it all looks great until you start looking at different things that can happen here. So this is a nice, gentle signal, and I'm taking my values here, and here's the thing that happens. Okay, how long is this duration here? Okay, if it's 1 hour, well, that's not too bad. In a day I'm going to have 24 samples. Okay, but if it goes down to a minute, then I've got, I believe it's 1440, and I probably should have figured that out before I started this. But anyway, as your interval shrinks here, the number of readings that you take grows. Okay, and so then this leads to a couple of different things. It takes a lot of storage space, which, disk space is getting cheap these days, so it's not necessarily a bad thing. I mean, I can go buy a 3 terabyte drive now, I think, for $150. But it also means that you've got a lot of readings. And so if I go back to get a year's worth of data and I've got, hundreds of thousands or whatever readings in here, then that takes time, and that's going to affect my retrieval performance. So, this right here, as I shrink this time, which I want to shrink it, I mean, ideally, I want to be able to take as many samples here as I possibly can because I don't want to miss anything. So the smaller this becomes, the larger my storage costs, and also I take a performance hit because I've got to read a lot more data from the disk in order to get my historical readings out of the computer. So let's look at another example here. Let's look at a signal that does something like this. Okay, so what's happening here? Let's say this is a value of 1. I'm reading 1, 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 and then something interesting happens, okay? Or maybe this isn't 1, maybe it's 0, okay? So maybe nothing's happening, this thing's off for a year, and then somebody turns it on. Well, if I'm taking a reading every second, I've just wasted a ton of database space, right? Because I've just got these 0, 0, 0, 0. And when I go back to retrieve this year's worth of data, I have to retrieve all these zeros. So it takes forever for it to read all that information off the disk and to transmit it across the network to my computer. And so I've just wasted a ton of space here when really I'm interested in what's happening here, right? This isn't very interesting. So there's one problem I run into, okay? So here's another problem. Let's say my signal goes like this, and then something really interesting happens and it goes like that again, okay? Now let's say I'm only taking my samples every 10 seconds. Okay, so there's the values that I just took, and so what it looks like happened, and let me pull up a different color pen here, make it red. So what it looks like here is that it did this and then came up a little bit and then went back down. That's what I'm going to see when I retrieve the data out of my historian, and I just lost this information right here. So that's a problem. Okay, but again, if I sample more often here and I'm storing every sample in the database, well then I just wasted a bunch of space here to capture that dynamicism here. So really what I want is I want to develop some sort of an algorithm or some sort of method for storing this data that doesn't waste a lot of space when this is happening, but captures all the dynamicism of that happening. Okay, so I want something that's going to maybe take a reading here and then maybe take a reading here, but then take a bunch of readings here and store them, right? I want to take all these readings in here. I want a bunch of readings because that's interesting. And then I want to go back to not doing this very often. Okay, and so it turns out that there's ways that I can do this. There's various methods that I can use that will not use a ton of space when I don't need to use a ton of space, and will use the space to capture dynamic stuff that I'm really interested in. Okay, and so one of those methods, there's a couple different things that I can do. And we've already talked about polling, right? So I'm polling my device. Let's say I poll my device every 250 milliseconds. So every 250 milliseconds I get a reading. Well, I don't want to store every one of those in the database, right? So one of the things I can do is I can do exception reporting. Okay, so I have my device and I poll it. Okay, so I'm doing my poll. And I'm getting back my values. I'm getting back V1, V2, V3. And like I said, I'm doing this every 250 milliseconds, right? So I'm taking a bunch of readings. All right. But what I do is I look at these readings as they're coming into my system, and I say, well, you know what? If these two values are the same, I don't need to store every one of them. So I say maybe as the values come in, okay, they're coming in here. And I say, okay, so this reading is virtually the same as this reading, is virtually the same as this reading, virtually the same as this reading, virtually the same as this reading. I don't need to read the. I don't need to save those. I can save this one right here, and then maybe every 8 hours or so, I'll save one just so that I know I'm putting something in my database. I know I took a reading. I know the system was operating, and I know if I say I'm going to do it at least every 8 hours, then I know if I don't have something in there for 8 hours. That I've got a problem with my system, but I'm throwing those out, and then when this starts happening, all of a sudden, well, these values are all different, right? So I'm going to save every one of those. So right here, I'm going to have more readings. Okay, so right there, I've already improved my situation, because when nothing interesting's happening, I'm not taking a whole lot of information. When something interesting happens, well, now I'm taking more readings, right? So this right here, this doing exception compression compresses my values, right? And so now if I go and I look at what's in my database, I'll have a reading here, I'll have a reading here, and I'll have a bunch of readings in here. But I've kind of optimized it because I didn't take a bunch of readings in here. So I'm going to store less data. Okay, so my storage space is going to be less. And my speed of retrieval is going to be better because I'll read a thing here, and I'm going to read a thing here, and then I'm going to read a bunch here. But I'm optimizing both of those. Okay, so that's kind of a neat thing. So that's exception-based reporting. Now I can actually get a little more. I can get a little more sophisticated than that. So we're going to talk about that in the next step.